$3. That is literally all it takes. Your mechanic just told you your transmission is completely toast at 120,000 miles. Yet, somewhere in rural Southeast Asia, there's a Toyota Hilux pushing 600,000 miles on its original gearbox. Over in Osaka, a Honda Civic Taxi is casually crossing the 400,000 mile mark without a single rebuild. Down in the Australian outback, there's a Nissan Patrol that hasn't seen a real transmission service since Jurassic Park was in theaters. And in the Philippines, a Mitsubishi delivery truck is clicking past 1 million kilometers on a gearbox that has never been opened. None of these transmissions hit the mechanical lottery. None of them got magical babying maintenance. Every single one of them survived because of the exact same $3 chemistry. It's a chemical cocktail that Japanese drivetrain engineers perfected back in the 1970s. And it's the exact same chemistry that the $180 billion Western transmission service industry has spent the last 50 years making sure you never ever see. You won't find it on a dealership menu. You won't see it recommended at your local Quick Lube. And it is completely absent from mainstream repair guides. What is it? It's a synthetic friction modifier. It's born from organometallic chemistry, and it literally bonds to the internal surfaces of your transmission at a molecular level. It slashes metal-to-metal contact by up to 50% compared to normal fluid, and it easily survives the kind of brutal heat cycles that cook standard automatic transmission fluid in a matter of months. Japanese heavyweights, Toyota, Honda, Nissan, Mitsubishi, have been baking this specific friction modifier right into their factory transmission fluids for their domestic market since the 1980s. The result? Their gearboxes routinely cruise past 300,000 miles on original internal parts. Meanwhile, Western transmission fluid companies are perfectly happy selling you a product that basically bakes under heat stress, demanding you come back and replace it every 30,000 miles. That massive gap between a $3 additive and a $5,000 rebuild, that is the forbidden math. That is the calculation they have spent half a century making sure you never do. They buried the science. Today, we're digging it up. If a shop has ever told you your transmission was slipping, if you've ever winced while paying for a rebuild, or if you're currently staring at a quote for $4 to $7 grand for a replacement gearbox, do me a favor. Drop the word transmission down in the comments right now. Make sure you subscribe and hit the bell because the next few minutes of this video are going to permanently change how you look at every car repair bill you ever pay. Let's talk about the money. The global transmission repair market rakes in over $180 billion a year. The big four brands dominating Western fluid culture sell hundreds of millions of quarts of ATF annually, entirely based on that 30,000-mile replacement cycle. But listen, the fluid isn't their big payday. The entry ticket is the fluid. The real revenue is the rebuild. When a transmission inevitably fails, and standard fluid chemistry practically guarantees that it will, the average rebuild in the US hits you for anywhere from $3,800 to $6,500. A full replacement? You're looking at $5 to $9 grand. With over 280 million cars on American roads, the math gets staggering. This massive repair industry doesn't exist because transmissions are just inherently fragile pieces of glass. It exists because the fluid sold to protect them was never designed to unlock their actual mechanical lifespan. Independent engineers have been shouting this from the rooftops since the 90s. There are two main assassins of an automatic transmission: heat-induced fluid degradation and metal-on-metal wear inside the valve body, clutch packs, and planetary gears. Standard transmission fluid breaks down under heat, accelerating both of these killers. But Japanese engineers functionally solved both of these problems decades ago, and they did it for $3. The Western transmission industry saw this $3 fix, looked at their business model built on catastrophic failures at 120,000 miles, and quietly swept it under the rug. To understand the fix, we have to go back to post-war Japan. In the 1950s, Japan's heavy industry was rebuilding from the ground up. They needed maximum efficiency. The hydraulic systems in their factories were running at screaming high temperatures and extreme shear forces, and conventional petroleum fluids were practically turning to water within weeks. They desperately needed a friction modifier that could take a thermal beating, survive mechanical shear, and permanently bond to metal surfaces to stop wear during 18-hour factory shifts. They found the answer in organometallic chemistry, specifically compounds derived from molybdenum and organic acids. When activated by heat and pressure, this stuff forms an incredibly tough, low-friction molecular shield on metal. It wasn't just a theory, it was keeping hydraulic presses alive in Nagoya and Osaka. By the late 60s, Japanese auto engineers had a light bulb moment. What if we put this in automatic transmissions? Honda was the first to really document it. Their research showed that adding these specific compounds to standard ATF actually dropped internal operating temperatures by 15 to 30 degrees Fahrenheit under load. That is huge. Heat is the ultimate grim reaper for transmission fluid. For every 20 degrees your transmission temperature goes up, the lifespan of your fluid is cut in half. So a 30-degree drop? You just effectively doubled the life of your fluid. But it did way more than cool things down. It chemically bonded to the metal. The clutch pack surfaces, the valve body channels, the planetary gears, every metal contact point got a microscopic suit of armor, reducing direct metal-on-metal contact by up to 50%. Toyota saw the same results. By the 1980s, Japan's largest petroleum company, INEOS, was brewing this chemistry directly into the standard factory fluid for the Japanese domestic market. It wasn't an aftermarket gimmick or magical mechanic in a bottle. It was the factory spec. This science was published in journals. It was presented at global conferences. Every Western oil giant knew about it, but they also knew exactly what doubling transmission life would do to their incredibly lucrative rebuild industry. So, how does it actually work inside your car? Think of your automatic transmission as a giant heat engine. Every failure mode is either caused by heat or sped up by it. The torque converter generates heat. The clutch packs generate heat every time you shift. The valve body sits in a boiling bath of fluid, eventually getting coated in varnish, which clogs up the precision channels and ruins your shift timing. Standard ATF has additive packages to resist heat. But resisting isn't preventing. If you tow, sit, stop, and go traffic, or live somewhere hot, standard ATF eventually taps out. The oil oxidizes, the additives die, the fluid gets thick, varnish builds up, and your gearbox starts its slow, expensive march toward the grave. The Japanese molybdenum-based chemistry steps in and attacks the problem on two levels. Level 1, it seeks out metal. Under normal driving heat and pressure, it forms a microscopic chemical bond with every metal surface. It's not a thick, gooey coating. It's a micron-thin molecular layer. It makes the metal so slippery that the friction coefficient drops by up to 50%. Less friction means less heat. Less heat means your fluid lives longer. It's a self-reinforcing loop of protection. Level 2, it stops micropitting. This is the real secret. Micropitting is what causes high-mileage transmissions to whine, shift hard, and eventually chew up their own gears. If you look at a normal 100,000-mile gear tooth under a microscope, it looks like the surface of the moon, thousands of tiny craters where the metal just ripped itself apart under pressure. Those craters cause vibration, which causes more heat, which causes more wear, until the gear is destroyed. But a gear protected by this friction modifier looks completely different. The molecular layer stops the metal-to-metal tearing. The gear stays perfectly smooth. Your transmission just keeps doing its job. To be clear, this is not a stop leak. This is not a band-aid for a transmission that is already blowing chunks of metal out of the pan. This is pure preventative science. So how do you actually use it? It's a strict 5-step process. Step 1, know your transmission. This is critical. Check your manual or your dipstick. You need to know if you have a standard automatic, a CVT, or a dual clutch transmission. For the vast majority of cars with standard automatics, the standard organometallic modifier is perfect. If you have a CVT, you must use a CVT-specific version. And if you have a dual clutch or a manual, check the product's compatibility list closely. Also, if you have one of those rare transmissions that specifically requires a friction-modified fluid from the factory, some very specific wet clutch CVTs, don't add more. More is not better. Overtreating can make the clutches too slippery. Follow the dose exactly. Step 2, add it during a fluid service, not randomly in the middle of one. You want this stuff mixing with fresh fluid. If you pour it into burnt, dirty fluid, the existing metal shavings and dirt will fight the additive for bonding space on the metal. Plus, oxidized fluid is acidic, which messes with the chemical bonding process. Fresh fluid equals clean metal, which equals maximum protection. Step 3, go for a 30-minute drive. And make it a real drive. Hit some stop-and-go city traffic to cycle through the gears, then jump on the highway to build up consistent heat and pressure. The chemistry needs that heat and mechanical pressure to actually activate and fuse to the metal. Once it bonds during that first drive, it's there to stay. Even when you drain the fluid at your next service, that microscopic armor stays bonded to the metal. You don't wash it away. Step 4, ignore the 30,000-mile myth. With a high-quality synthetic ATF and this friction modifier, your service interval safely stretches to between 60,000 and 100,000 miles under normal driving. That 30K recommendation, that's for their wallet, not your car. Independent oil analyses constantly prove that this modified fluid stays fully protective well past 60K. If you do severe towing or heavy commercial driving, dial it back to 40K to 60K. But you do not need to dump your fluid every 30,000 miles. Step 5. Watch your temperatures. If your car has a transmission temp gauge, keep an eye on it. If it doesn't, grab a cheap $15 Bluetooth OBD2 scanner from Amazon and load up a free app on your phone. Watch your temps for the first 1,000 miles. You will literally see the science working. A properly treated gearbox will run 15 to 30 degrees cooler than it did before. It's not placebo, It is measurable proof that the friction inside your transmission has been neutralized. If you want absolute undeniable proof of this, look at the Japanese taxi industry. Tokyo and Osaka taxis live in absolute hell. Endless gridlock, thousands of shifts a day, constant low-speed heat. It is the ultimate transmission torture test. Yet, major fleet records show these cars, Toyota Crowns, Nissan Cedrics, routinely blowing past 300,000 miles before needing any major gearbox work. They run the Japanese domestic fluid with the built-in friction modifier. Meanwhile, identical cars running standard Western fluid in Western cities are blowing up and needing rebuilds at around 150,000 miles. It's a 40% difference in lifespan, entirely due to $3 worth of chemistry. We see it stateside too. A regional delivery fleet in the American Southeast running 42 heavy-duty vans in brutal heat was eating transmissions alive. They went through 5 complete replacements in 7 years, averaging $5,800 a pop. In 2017, the fleet manager got smart. He switched to synthetic ATF with the organometallic friction modifier and pushed their service intervals to 80,000 miles. Fast forward 7 years to 2024. The result? 0 failures, 0 rebuilds, 0 replacements. Over half the fleet crossed 200,000 miles, and lab tests showed the fluid and internal wear were still perfectly in spec. They cut their transmission costs by 58% practically overnight. It wasn't magic. The additive just quietly eliminated the heat and wear that conventional fluid allowed to happen. It didn't ask for a follow-up appointment. It didn't hand them a 4-figure invoice. When you manage the heat cycle with molecular surface bonding instead of cheap petroleum, a transmission does exactly what it was engineered to do. It lasts forever. The difference between a transmission dying at 120,000 miles and one cruising past 350,000 miles isn't the brand, and it isn't the mechanic. It's that $3 chemistry. While Western companies spent 50 years optimizing how quickly they could get you back into the rebuild bay to turn a $3 fix into a $5,000 bill, the engineers in Japan were just making sure the cars actually worked. That $180 billion industry relies on you never doing that math, but you just did. If you want to protect your own car, the exact additive we've been talking about is the Liqui Moly MoS2 anti-friction treatment for automatic transmissions. You can grab it for a few bucks at almost any auto parts store or online. I've dropped all the exact product specs and application ratios in the description below. Protect your gearboxes, keep your money in your pocket, and I'll see you in the next one.